Okay, y'all. Welcome to your last week of material for distance learning. Can you believe it? What we're talking about today is probability again, and we're focusing on independent and dependent events. So the front of your notes is about independent stuff, and the back will be for dependent. So let's just set up with some definitions first for independent events. Events are independent. By events, we mean what's happening, like you're rolling a die, you're spinning a spinner. The events are what's happening after each roll or each spin. And you could say that they are independent if the occurrence of one event does not affect the probability of the other. So for example, if I'm flipping a die and I flip it and I get heads, that has absolutely no bearing on my next flip. My next flip, both events are equally probable. Okay. If A and B are independent events, then the probability of A and B is this. The probability of each of them individually multiplied, right? We're going to multiply those. And when I say the probability of A and B, I mean you're doing your experiment multiple times, and what's the probability of different outcomes occurring over the entire experiment. So we have this first example. A six-sided die is rolled. Determine the probability of the following. What's the probability that you roll a 3 2 times in a row? So we're asking for this. We're asking for the probability that you roll a 3 once, and then you roll a 3 again. So there's your A and B from this notation right here. And what that means is you're just going to find the probability that you roll a 3 once and multiply it by the probability that you roll 3 the second time. Because these are independent events, the probability is the same each time. Okay, it's 1 out of 6 because you had 6 possible outcomes, but only one is the 3. And for the second roll, it's also 1 out of 6. And when you multiply fractions, you multiply across the top and bottom. So we would say that's 1 out of 36. That's the probability that you roll a 3 2 times in a row. And remember, if you wanted, you could convert that to a decimal and then a fraction if you needed different representations of that information. For example, if you convert it to a decimal, it'd be 0.027, and as a percent, it's 2.77 or 2.8%. So the chances of you rolling 3 2 times in a row is 2.8%. Rolling a 4 and then a 6. So think about that for a second. There's no magic about whether you're rolling a 3 each time from part A, or a 4 first and then a 6 second for part D, because they're all independent of each other. So it should come out that it's the exact same probability, right? Even though the numbers are different. So let's figure that out. So we want the probability that we roll a 4, and then the probability that we roll a 6. So the probability that you roll a 4 is the same as part A, the probability of rolling a 3. It's 1 out of 6. And that also is true for rolling a 6 on your second roll. So this is still 1 out of 36. So then part B here, rolling a 3 3 times in a row. Well, you can imagine it's just 1 out of 6 for the first roll, 1 out of 6 for the second roll, and 1 out of 6 for the third roll. And then you multiply across the top and bottom. 6 times 6 times 6 is 260. For part E, so now we're changing things up a little bit. What's the probability that you roll an even number first, and then you roll a 6? So we want the probability that we get an even number, and that will be multiplied by the probability of rolling a 6. Well, the 6 we already know, okay? The probability of rolling any one number is 1 out of 6 numbers. To figure out the probability of an even number, you have to count up how many even numbers there are, right? So here are the numbers on a die: 1, 2, 3, 4, 5, 6, and there are 3 even numbers. So the probability that we roll one of those is 3 out of 6. And you could multiply straight across here and get 3 out of 36, and then simplify by dividing both of those, the top and bottom, by 3 and getting 1 over 12. If you simplified the 3/6 immediately and got 1/2, you'd still get the same answer, because now you'd have 1/2 times 1/6, which is still 1/12. 1 over 12, 1 out of 12. So I want you to pause the video and do C and F on your own. So rolling an odd twice in a row. Now, there's the same number of odds that there are even. There's 1, 3, and 5. So it's still 3 out of 6, or 1/2 probability that you roll an odd. And if you're going to do that twice in a row, it's 1/2 is the probability for rolling the odd the first time. And 1/2 is also the probability that you roll an odd the second time. And we just multiply those to figure out our total probability. It's 1 out of 4. And F wasn't interesting. I hope you figured that one out. The probability of rolling a number less than 7. All the numbers are less than 7. So that probability is 100%, right? Or 1 if we're using, you could say it's 6 out of 6 or just 1. That's the probability of a number that is less than 7. And then for your second roll, so you're going to multiply that by your second probability, which is rolling a number greater than 7. Well, what is that? That's 0, right? There are no numbers greater than 7. So technically you could say that the probability of that is 0 out of 6 possible outcomes, but that's just 0. So 1 times 0 is 0. There is 0 probability that that is going to happen for you. Because when we're talking about this compound event, like more than one thing happening, you have to take both of them together. We said that is 100% probability you're going to roll a number less than 7, but you will never get that second event. So when you take both of those events together into one bigger situation, it will never happen. All right, example 2. We're switching over to combining a die with a spinner. So example 2 says, given a 6-sided die and the spinner, determine the probability of the following. Okay, we're still multiplying the probability of each individual event. So part A says rolling a 2, okay, that's with the die, and landing on a 2. So the probability of rolling a 2 is 1 out of 6. Okay, we've been doing that. Times the probability of spinning or landing on 2. Well, let's look at that spinner for a second. How many possible outcomes are there? So you want to count the individual things. There's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 sections to that spinner, so there's 8 possible outcomes. And how many of those are 2's? 2 of them, right? And so if you multiply across the top and bottom, you have 2 over 48, which simplifies to 1 over 24. Okay. And if you had simplified that to 1/4 before multiplying across the top and bottom, you'd have the same answer. Okay. So pause the video and do B by yourself. So the probability that you roll an even number, we said before, is 3 out of 6. And the probability of landing on a 1 is 2 out of 8. And we multiply those. So that is 6 out of 48. Divide both of those by 6. That simplifies to 1 over 8. And you'd get the same thing if you simplified the fractions before multiplying. So that would have been 1/2 times 1/4, which is 1 out of 8. So that's the front of your notes for independent events. Now we're going to talk about dependent events. So this is the back. So where independent events affected the outcome, or I'm sorry, did not affect the outcome of the probability of the other, dependent events absolutely do. So events are dependent if the occurrence of one event does affect the probability of the other. And we would call this conditional probability. Conditional probability is used to find the probability of dependent events. And we're going to write that one, this notation like this. The conditional probability of B and A is the probability of B given that A has occurred. Okay. So this is saying, what's the probability that B happens if A has already happened? Okay. And if A and B are dependent events, then the probability of A and B is the probability of A times the probability of B given that A already occurred. So A happens first, and it affects the probability of B happening after it. So let's look at some examples. And we're still going to be multiplying those probabilities. So a picnic basket has 10 sandwiches, 2 ham, 3 turkey, and 5 peanut butter. A sandwich is selected at random, eaten, and then another sandwich is selected at random. Determine the probability of the following. Okay. So the first example is, okay, a turkey sandwich gets selected first, and then a ham sandwich second. So that's what we mean by the first thing affecting the probability of the second. Because once a turkey sandwich is removed, the total number of possible outcomes has now changed for when you go to choose your second sandwich. Because when you select the turkey sandwich first, there's 10 possible things to choose from. Once you eat it and it's gone, and you go to when you go to select your ham sandwich, there will be only 9 things to choose from. So the probability will have changed. So let's talk about the turkey sandwich first. There are 10 possible outcomes, 3 of which are turkey. Okay? Makes sense. And then we're going to multiply that by now selecting a ham sandwich after 1 turkey sandwich has been eaten. So once 1 sandwich has been eaten, there are now 9 possible outcomes for sandwiches you can choose from. And we're going to be choosing a ham sandwich next. How many ham sandwiches are there to pick from? 2. And now we multiply across the top and bottom. 3 times 2 is 6. 9 times 10 is 90. We can divide 6 out of both of those. and that would give me 1 over 15. The next example is going to work the same way, only now we have 3 events happening. So we're starting over from scratch. We're not continuing from part A. We're going back to the original problem. Selecting a turkey sandwich. Out of 10 possible things, how many could be turkey? 3. Then a ham sandwich. Once the turkey sandwich is gone, there's 9 sandwiches left to choose from, 2 which are ham. And then a peanut butter sandwich. Okay, well, we've already eaten 2 sandwiches. So once we get to our third choice, there are now only 8 sandwiches left to choose from. 5 of those are peanut butter. And we're going to multiply all those together. That is 30 over 720. Divide both of those by 10, you get 3 out of 72. And divide both of those by 3, you get 1 over 20. You pause and try C on your own. All right, so selecting 3 turkey sandwiches in a row. Just like normal, the first probability is 3 out of 10. 10 sandwiches to pick from, 3 of which are turkey. So now that turkey sandwich is gone. There are 9 sandwiches to choose from for the second choice. Now, how many turkey sandwiches are there left to choose from? 2, right? Because we already ate one. So now we've eaten 2 turkey sandwiches. That means there are now, for the third turkey sandwich, there are 8 sandwiches to choose from, and only 1 of them are now turkey. So we multiply across the top and bottom. Now we have 6 over 720. And then we divide 6 out of both of those. And the probability is 1 out of 120. So if you chose 3 sandwiches in a row 120 times until you got all 3, it would take you that many times. Chances are it would take you that many times before you got 3 in a row. Now pause your video and try D. Now you might feel like the D is exactly the same as C, so therefore they should have the same answer. But the reason why you're not going to get the same answer is because they started out with different values. There was 2 ham and 3 turkey, right? So you kind of have to think about this one for a second. If you just used your brain and no math, what's the probability that you would get 3 ham sandwiches in a row, considering that there was 2 to start with? 0, right? That's not going to happen because it's not possible that that third sandwich could be ham. But, you know, because this is math, let me just show it to you using math. So the probability that the first sandwich is ham is 2 out of 10, because there's 10 possible sandwiches, 2 of which are ham. You remove 1, there's 9 sandwiches left, and you've eaten one of the hams. So now there's only 1 ham sandwich left that you could possibly pick. Now you've removed 2 sandwiches, there's 8 left, but you've eaten both of the hams. There are 0 hams left. So when you multiply across the top, you get 2 times 1 times 0, which is 0. And on the bottom, you still have 720. And what is 0 divided by 720? 0, absolutely. So that's 0%, 0 chance that you're going to get 3 ham sandwiches. All right, so that's what we mean by conditional probability. The first event that occurs affects the outcome of the remaining events. It's different from when you're just rolling a die, right? You can, rolling a head the first time has absolutely no bearing on whether you're going to get a head the second time. All right, so last example. 2 cards are drawn from a deck of 52 playing cards. Determine if the events are independent or dependent, and then determine the probability. All right, so example A. Selecting 2 aces when the first card is replaced back into the deck before drawing the second. I want you to pause and just think about whether you feel that's dependent or independent. So that is independent, right? Because when you replace the card back into the deck and you go to draw a card the second time, the circumstances are exactly the same as the first draw. You haven't changed the possible outcomes, or you haven't changed the probability. So the first probability is drawing an ace. Do you know how many aces are in a deck of cards? There's 4, right? So out of 52 possible cards, there are 4 aces. When you return the ace to the deck, you replace it. How many cards are there possible for you to draw from? Still 52, right? And it's still the same 4 aces that you could possibly draw. So then we multiply those together. Actually, I'm going to simplify here because 52 times 52 is pretty big. So these both simplify. 4 can be divided out of each. So I'm going to simplify 4 over 52 as 1/13. And this one as 1/13. And then multiply. 1 times 1 is 1, and 13 squared is 169. In part B, selecting 2 aces when the first card is not replaced before drawing the second. I want you to pause, think about if that's dependent or independent, and find the probability. Pause and do those things before you come back. So I hope you came up with that these are dependent events. These are like our sandwiches above, right? The probability of getting an ace the first time is 4 out of 52, just like above. But if you're not replacing it, so the probability that you get an ace not replaced. Well, you haven't put the card back in, so now how many cards are there to choose from? 51. And you didn't put the ace back in, so now how many aces are there to choose from? 3, right? And so we multiply those together. I'm going to simplify this again to 1 over 13. 3 over 51 does not simplify. So multiplying across the top gives me 3, and across the bottom gives me 221. And for me, this is just an aside, just some random information. 1 out of 169 for A, your brain is kind of like, okay, yeah, that's pretty small. I don't, you understand that that's true. But when you start seeing numbers like 3 out of 221, or if you had like 12 out of 221 or 15 out of 221, then it's kind of harder to understand exactly what that number represents. And that's why it's helpful to remember that you can always you can always rewrite this as a decimal in a percent. So if you did 3 divided by 221, you'd have 0.01. If you multiply by 100, you come up with, oh, okay, that's 1.35%. And now it's easier to understand actually how low of a probability that is when you convert it to percent. Okay, back to the notes. Selection a face card. It should say selecting, right? Selecting. Selecting a face card and then a 7 when the first card is not replaced before drawing the second. So let's talk about face cards for a second. Maybe you haven't played cards recently, but face cards are jacks, queens, and kings. Okay, and there's 4 suits in a deck. There's the, see, I can't remember, hearts, clubs, diamonds. Hearts, clubs, diamonds. Oh, good heavens. I have to go look it up. I'll be right back. Hold on. Spades. I can't believe I had to go look that up on the Google. Hearts, diamonds, spades, and clubs. All right. So there's a jack, that's hearts, diamonds, spades, and clubs. There's a queen, that's hearts, diamonds, spades, and clubs. And there's a king for hearts, diamonds, spades, and clubs. So how many possible face cards is that altogether? There's 12, okay? So how many face cards are there altogether? 12. So we need that information just to get started. So let's talk about then about the first probability, that we select a face card and then a 7, blah, blah, blah. All right, so here's the first probability. The probability that you get a face card is 12 out of all the cards possible, which is 52. But then we want to know the probability that we get a 7 when the first card is not replaced before drawing the 7, okay? So times the probability of 7 with no replacement. Well, this illustrates clearly whether this event is dependent or independent, right? If we don't replace it, then the probability of getting a 7 changes from what it would have been originally. So not replacing it affects the outcome of getting a 7. So this is dependent. Right, so now without replacement, there are 51 cards to choose from for the 7. And how many 7s are in the deck? There's 4. There's okay, let's see if I can remember them without Googling again. Hearts, clubs, spades, and diamonds. Okay, hearts, clubs, spades, diamonds. Okay, there's a 7 for each of those suits. So there are, no, I'm sorry, there's, my gosh, get a new teacher in here stat. There are 4 7s altogether. I'll get this straight in just a second. And so we're going to multiply these values. If you were to simplify 12 over 52, you would get, 4 comes out of both of them. So you get 3/13. And then multiplying across the top and bottom gives you 12 out of 663. And that can simplify one more time because 3 comes out of both of those. 4 out of 221. And see, for me, my brain is like 4 out of 221, all right? But what on earth does that even mean? That's kind of abstract for me. So if you convert to a decimal and then a percent, that means there's 1.8% chance that this event, this combination event would actually occur. Okay? So now go do your, what do you have this week? You have just, let's see, a practice worksheet and a riddle worksheet. And that's it. And that's only this one lesson. So congratulations on making it through your distance learning.